Welcome to episode number 5 of the Structural Engineering Podcast. We're your hosts. My name is Max.
I'm Zach.
We're here to talk about structural engineering. This week we got a topic that's near and dear to our heart. What are we talking about?
We're talking about 3D printing.
Yes.
Yeah. Max and I both enjoy 3D printing. We do it as hobbyists, and as you can see, we have some things here on the desk. If you're listening to the podcast, we have a beam splice connection that's 3D printed. We have some 3/4 inch bolts that are printed with nuts. And we also have nice big tower from New York.
And we're not just talking about printing entirely unusable bolts.
Hey,
I'm
going to hold something up with these.
We're talking about printing buildings. Printing buildings with concrete and printing buildings with a little bit of steel. There's some people doing all sorts of stuff.
It's in the news right now a lot. There's a lot about 3D printing houses, 3D printing skyscrapers. I mean, people are really trying to get into this industry.
It's very cool.
And so we think this is a perfect topic for us to talk about because we both enjoy 3D printing. We know about 3D printing, and we practice. Work as practicing engineers, so structural engineers.
Covers 2 bases.
So
let's get after it.
It's a fun topic for us. So I guess to start off with, what is 3D printing? I mean, how would you describe it? And really, I mean, if you haven't seen a 3D printer, we'll try to post one in this video with the podcast, kind of show people what it is. But they do something called FDM, which is fused deposition modeling. More or less, you go layer by layer, fusing the previous layer to the newer layer with some sort of adhesion. And usually with traditional 3D printers that are printing plastic, that's because the next one's a little melted, so it just adheres to the previous print. With FDM printing, it's very traditional that's your failure plane. You have these horizontal, let's call them cold joints, and that's where you'll see the failures. There's a couple other different types of 3D printing. The other types more or less use lasers to harden some sort of material. And those are more monolithic and they don't have layering. And they've done a lot of testing and used very high powered microscopes to look, and there isn't really layering at all. Yeah, and so those aren't breaking in layers; they're breaking more like a monolithic, cast part. So
I guess if you haven't seen it all, it's like if you were to do this, lay toothpaste on your bathroom counter, and it makes this nice little layer, and then if you do that a bunch of times, you make a little toothpaste castle.
Absolutely.
So that's you haven't seen this ever.
Yeah. So that is 3D printing, and today I think we should probably talk about printing houses.
Yeah.
I think
that's super cool.
The big thing the industry's jumping into right now. There's tons of articles, white papers. The ACI even has a committee discussing it. The American,
which is unreal. That's a big move. I mean, that means this is happening.
The Concrete Institute is having a whole committee. So, I think it's pretty big.
Yeah. I don't know. Let's talk about some of the projects that are going on right now. We just did a little investigation for this, and we know some of the projects that have gone up. So far, mostly houses, right?
Yeah, almost
exclusive. Well, there's been some offices.
There's some walls and things like that being built.
Some barracks. So there's a bunch of people getting into this.
Yeah, the United States military has patents.
Have a patent on this.
Yeah,
making barracks quickly.
Yeah, I believe they have a patent on the mix.
Oh, do they? Okay.
Yeah, which the mix is probably the most tricky thing to do. Just like traditional 3D printing, where you use filament, which is a strand of plastic that runs through the printer and melts. Bad filament, bad print. Bad concrete,
bad print.
Bad print. Bad house, bad barracks or whatever. So they're finding that it's it really is the mix, and some people are adding fibers to the mix that you traditionally do. Not it's very non-traditional concrete design. There's some purposes for it, but
maybe before we get into what are the issues, is what are people making right now? Besides houses, there's a lot of companies doing this, right? We saw an article, top 11 There's the top 11. There's a lot more than that, right? So
there is.
Everyone's got some different styles.
Yeah.
These are mostly houses. A lot of different types of printers. Some are stationary. Some can move around.
Mm-hmm.
They are all printing with concrete or a cementitious material.
Yep.
Some are putting some version of reinforcing either in the mix as they're printing or after the fact. Someone comes in and lays down a ladder reinforcing.
Mm-hmm. After each layer.
Or you know,
every
as
cell.
needed. Yeah. What else? What are the commonalities here? You can't print a roof.
That's the biggest issue. Yeah.
You can't print everything. Right now, I mean, the nozzles are pretty big. Like, you can't print a little place to put a socket, right? Like, all this stuff has to be cast in by hand.
Yeah.
Still fairly rudimentary as far as regular 3D printing. You know, like the stuff we've got lying around here, the detail on this is nuts compared to a 3D printed house.
Absolutely.
But the fact that you can have a truck pull up and plop a house out.
Yeah, so, I mean, it's going to take construction times down to nothing.
Yeah.
I mean, the house, the one that's been permitted in the United States and Texas, I believe San Antonio, Texas.
Is that 48 hour?
Was one day.
24 hours.
24 hours. Now, the article is not very clear if that was 24 hours to print the house or if that was 24 hours for the whole house.
Yeah.
I don't think it's going to be for the whole house because there was a foundation they poured. There is a roof that was wood frame. So
what was the coolest of the ones we were looking into? What do you think has the most promise? Like so far, you know, I
promise
think
for practicality.
Promise for practicality. I bet in 10 years, all this is gonna be so different. So this is, you know, you got to start.
Yeah.
But
in 10 years when we do a podcast then and talk about this again, we can look back at this moment. I really think the housing industry is really where it's going to take off.
But which of these companies do you think is going down the best path at the moment? Company / the Army Corps.
Yeah. That's a tricky one. The one that's most in the news that really I feel I can talk to better to is the one in Texas.
Yeah.
They've actually permitted a building through the building department.
Which is huge.
Yeah. A lot of new material that are being, used. Usually have to go through testing, or you have to come up with a whole, more or less thesis on why it's okay and deliver that to the building department.
Mm-hmm.
And so they've gone through those steps to do that. So this company, in my eyes, has the best chance moving forward to producing more. And they have are now collaborating with a charity to go down to Mexico and build a whole neighborhood of these houses for people.
That's right. Do you know the name of this one? If we want to post it, someone wants to look it up. I feel like it might be Icon. Is this one Icon?
Yeah, this is Icon.
Okay.
Yeah.
We'll post the links, but
we'll have the link in the description of all of our.
Oh no, Icon is working with them. Icon is a robotics construction company.
Yeah.
ICON.
We'll post it.
Yeah, we'll get it up there. Yeah, I agree. They seem the most professional as far as not professional, but
their whole staff is mechanical engineers.
They know.
Well, we talked to David. They know about boats. No.
Well, that's cool. Yeah, they're building. They're trying to build 100 in Haiti, which I'm sure they will. Right, they're raising funds for it now.
Yeah, absolutely. I mean, at $10,000 a house. I mean, that's raised for a nonprofit. Yeah, they said all said and done. I think that was the printing cost, foundation, the roof, electrical, sewer.
Yeah.
I mean, I think that's it. All ground up.
Man,
$10,000.
That's awesome.
I mean,
that is so cheap.
Right now, we've been looking at like houses a little bit in the area. Right, we're in Colorado, and like a starter home is ridiculous.
Yeah.
But think if your starter home, you could get out of high school. I think this is really exciting. I really like this. Is you get out of high school and buy a $10,000 house.
Yeah.
Like something very reasonable. Maybe it's the house is that, but the land's a little more. So $50,000, $60,000.
Yep.
For a property and a house. I mean, that's amazing. And you could buy maybe a lean-to or something like that for a little garage, or 3D print the garage too. You know, and then put some gable trusses on it. Man. I mean, I think how cool that would be.
Yeah.
You graduate high school and go buy a house like on minimum wage. That's where I think is very exciting. This technology. You can have that ownership.
Absolutely, and I think this technology is just totally unstoppable. Like, this is not going to be a fad.
No.
Construction will be robotic.
Yeah.
No doubt in 50 years. Probably a fair bit robotic in 10 years.
I mean, if you take another industry, the health industry, surgeries are done robotically.
Yeah.
A lot of times. Big surgeries. I wouldn't say a lot of times. They're in certain hospitals and stuff, but I mean, we're taking that, to the robotics level, right?
I want to get LASIK. I don't want somebody to shine a laser in my eye. I'd rather a robot do it.
Yeah. Yeah, no, absolutely. I think that's where everything.
Yeah.
I mean, everything's going to it. There's no. I mean, someone that says not, they live in a fantasy world.
Yeah.
So, I mean, like we talked earlier today, there's a company out there that has a bricklaying robot.
Yeah.
Right? I mean, it's
slow now.
Yeah,
it's not
slow, inefficiencies.
But it's there, and it's going to be a lot better soon.
You have to start somewhere.
Yeah,
right?
Exactly.
Well, we started with man. Now we're using this technology to gap that speed, that efficiency. I'm sure there'll be lots of worries about jobs and whatnot, but I mean, technology, you have to have people that can develop it and run it and maintain it. I mean, so there's lots of things with that as well. But anyways, yeah. So going back to that company, I think what they're doing is amazing.
Yeah.
I really want to reach out to them.
Do it.
Yeah.
I guess. We talked about you.
If you're listening to our podcast, you're one of our few. We like you.
What else? Okay.
So yeah, I guess where do you see this going? Like we said, we see it's going to go full robotics. I think all
construction will be full robotic.
Where do you see the technology today versus in a year, 5 years, 10 years, 20? I mean, how fast do you see this innovating? How fast do you see it coming into this country?
I mean, there's some big issues potentially. I keep just staring at the screen of the printer over there. Like,
yeah. We have a
printer on
screen up, yeah. It looks like a spider.
Insulation
you know what
stands
they use
out
that
as an
base
issue?
for?
Moving?
No, they have a this is kind of cool. They have this like spider base thing that looks just like that, and they use it on the Burj Khalifa tower. That it sits inside, and then it grabs window panels and it puts it outside the building and drops panels down and pulls them close to the building. And it's got this whole spidery base. It's really cool. I'll show you a video of it later.
Wow. Anyways, yeah, I mean, the places these have been used have been warm climates, right?
Yeah.
These currently aren't insulated. They're pretty lightly reinforced. We've seen some ways to reinforce them, but across the board they are pretty sensitive to shear, right? They break at the layer boundary.
For
more likely
plastic layer, yes.
Yeah.
So, but if we're thinking this is a cold joint,
as a cold joint,
sort of,
they are more likely to break.
Correct.
Be careful with the wording.
But what do you think, as an engineering judgment?
Yeah.
These houses that are being built, 1 story, small footprint. Would you see any issue with that? That whole, I mean, could you see that whole house shearing?
No way.
Yeah.
So one thing I saw, this is not answering a question.
Yeah.
One of the issues is
you're a good politician.
Expansion contraction.
Yeah.
Like shrinkage cracks, not so much temperature.
Shrinkage.
But
when it gets real cold.
Yeah, these so far the mixes have shrunk a lot more than a typical concrete mix.
Mm-hmm.
So you have way more shrinkage cracks, and they're probably going to be forming at the weak planes, which are probably the boundaries.
Yeah.
So, I mean, I could see conditions where you have a crack around the entire structure at the same level.
Yeah, absolutely. You see that a lot of times with a concrete roof sitting on either concrete or masonry walls. That roof starts to come up and it pulls off the wall.
Yeah.
I mean, they're still reinforcing between the two, but it starts gapping it.
Yeah. If there's reinforcing,
still good.
Who cares? Yeah, go for it. I saw a cool fix for this boundary thing.
Oh.
This was the first ever concrete bridge. It's gonna be hard to explain, but they print on a flat plane. So you're printing on a table, so layers are coming out at you, and they basically print a box girder, and there's some infill on it. So then they print a bunch of these things. It's about 8 feet wide and maybe 3 feet tall, and they flip them up, and then they post tension them together. So there's these panels on each side, and they squeeze them, and that is like a pedestrian bridge. So they're getting away from like the failure plane, this like natural, not issue, but kind of one of the little problems, like concrete not so good in shear in general.
Yeah. It's definitely not good in tension.
It's definitely not good in tension.
So tensioning the concrete.
So yeah,
putting compression into it is good.
They tension the heck out of it.
Yeah.
It looked pretty cool. Netherlands.
Yeah, I think they would be the one country in the world to innovate on bridges. I mean, they've got probably the most bridges in the world.
Yeah.
Or close to it. They're a small country, but yeah, they got some cool bridges. I don't know if you've seen some videos.
Been there.
Of course you've been there. You rode bikes on the bridges?
Yeah.
Gosh, you're a boss. Couldn't you guys? You talk to Max about riding bikes on bridges. Email us.
Yeah.
Okay. Anyway, so where do you see this going? So you're seeing fixes.
I think we'll see houses being printed, meeting code standards, or if not meeting code standards, being printed, approved by local municipalities like smaller cities, saying okay to 3D printed concrete houses in 10 years.
Why is that?
I'm just thinking about the Earthship guy. Mike Reynolds is this architect that builds these rammed earth homes out of tires.
Yeah.
So he stacks all these tires and pounds dirt on them. Did an internship down there once. It's really hard to pound earth into a tire. But, right, and it's super hard to test. It's hard to inspect. Like, intuitively it's not going anywhere. A one-story pile of tires,
Oh, yeah.
Low center of gravity. It's high inertia.
I mean, they have houses built out of mud.
Yeah, exactly.
Around the world, right?
Yep.
I mean, the U.S. is a different animal.
Yeah.
But
they can exist. So these houses for a long time had to be built in this what's called like black land in New Mexico. It's like just land without any jurisdiction, more or less.
Mm-hmm.
Just open desert. They could build them. And now, not now you're starting to see, but like 10 years ago, you started to see these things pop up. Like we have one where we're at Fort Collins.
Yeah.
There's a house made of tires and dirt. And it's a perfectly reasonable house that the city allowed to be permitted. I had done an inspection on it once, actually, and yeah, it's weird.
Wow.
I know. That's how I know about it. And so they, where was I going with that?
I don't know.
Yeah, it's there. Oh, they were saying like the city wanted to come out. Their inspectors were just on site a lot more. They wanted to see how this thing was put together. Was it really reinforced? Did it seem sturdy to them? And they, so they wouldn't give the permit from what I'm at here until, they basically said like, give it a try, start building. Halfway through, we might say, never mind, this doesn't look stable. But the people were into it. It's pretty expensive to try. And so they went for it, and the city said, yeah, that looks like a stable structure.
What did you think?
Oh, I think it's totally stable. It settles a lot.
Okay.
Because you don't,
makes sense.
There's no consistency, so if you don't pack down one of the tires very well, that one's going to settle a bit.
Yeah.
And there were some cracks. I mean, it's never settled, but
cracks are okay sometimes.
Cracks are okay. Yeah, it wouldn't go anywhere. The house is not going to fall down. No way. But if you plaster a flexible wall, things happen.
Yeah. Learn your deflections.
Yeah. Your deflections. Yeah. But so I see this kind of going the same way. Is it'll come around, and I don't think it'll be as long as that, because I think 10 years is pretty reasonable to have. We already have one in Texas,
like
right?
Most
maybe even less. We're maybe not most, but under 50%.
Smaller.
Yeah, smaller towns.
Because you can use that.
I don't think
you're
going to build one in Denver or like LA, but I think it's reasonable to build one outside of
in a suburb.
In a suburb, yeah.
Yeah.
Probably smaller cities that are willing to play around with this stuff.
Yeah.
Got some time on their hands, I guess.
Yeah. No, absolutely. Yeah, I think we'll see construction becoming more and more
automated,
driven by technology and automated. I think like a good starting point maybe with 3D printing houses is 3D printing foundations.
Yeah.
I think that would be a very good first step at it. It'd be hard to monitor and to track and to see, but doing something like that, and like you brought up, I guess we haven't talked about it yet here, but about you 3D print the walls, and I guess we haven't done a really good job of explaining exactly what that looks like, but it's more or less two faces with an air gap in between, and maybe kind of a lattice structure, a ladder structure in between. And then what they can do is come back and fill that with grout and reinforcing.
Yep, like CMU.
Yeah,
right.
So it would be a good alternative to CMU if it is cost effective, and if they can figure out a good way to finish it. So you kind of get this like, kind of each layer is kind of
looking thing.
Yeah,
just sort of lumpy.
You can lumpy layer by layer. I've seen a couple that look better, but I don't know how. I think they finished them.
They stucco them.
They
or
stucco them,
smooth
yeah.
concrete. Or shotcrete or something might be a thing. I don't know.
Yeah, no, there's many.
Some sort of reinforcing.
Yeah, different methods.
I mean, you could put like a reinforcing mesh on the outside and shotcrete it even.
Yeah. But you could do that
with anything.
With it, just like.
Well, that's what I've seen this on. I don't know what it was. Some existing concrete wall. They were changing the occupancy of the building, and they needed the wall to be stronger. Did we see the same time? I don't know what this is from. And they put reinforcing on the wall and shotcreted it on.
Oh yeah, I've done that a couple times on retrofits.
Okay, yeah. I mean, I guess you
dowel them together.
Not robotic for. That's not robotic.
No, could be.
There will be an answer in some time, 10 years, that it will be completely robotic.
Yeah.
But for now, there's going to be, I think, a lot of intermediate steps.
Yeah, 100%. I think there has to be a lot there. It has to innovate a lot. Yeah. I don't think it's very consistent, and currently it hasn't been reproduced over and over and over and over again, right? So the more they do that, the more it'll innovate. The quicker it'll get, the better it'll get, the faster it'll get. I would be really excited to see a company put this thing on a shake table.
Oh yeah.
I think it'd perform fairly well. I think you would see some delaminations of the layering. But I think you could do pretty well depending on the system they use. Some put down some layers, like you said, and then put down like a mesh of some reinforcing. There's also some mixes where they're using fiber reinforcing. They're using carbon fiber reinforcing.
Oh, cool.
Those little strands. Yeah, I think that makes sense. They're sticking out.
Oh yeah.
The next layer comes and sits in
great. I think will be a weird hurdle is that the houses look not like your traditional American, salt box home or whatever you call it.
Yeah.
Just like it's not a square box.
That's a good. That's a really good point to make especially with your background in architecture. Like you'd be the person to talk to that, because most structural engineers would be like, "Nah, that looks sweet because it's very structural."
Yeah.
It's very.
Oh yeah.
Structures up front. Industrial, like that whole
architect's
nightmare.
Is what, yeah, I think that's going to be a big leap. Is like people have to be okay with the look of this. Like they have to grow comfortable with how it looks.
Yeah, I think in Australia they have these big mounds that are built up by ants, or maybe they're cockroaches. No, like they're like.
I don't
these
think
huge,
they're cockroaches.
I can't remember what they are, but they're these huge like organic structures that come out of the ground, and I think it looks very like similar to that. I think it's becoming to look more organic.
That sounds beautiful.
Yeah,
like a cockroach mound.
Yeah, and I think talking on that line with steel 3D printing, and I think this is probably for another episode, but like 3D printing bridges out of steel, I think you're going to see more and more organic shapes.
Oh, absolutely. Because you can
being
just
allowed by this
entirely optimize.
You can thoroughly optimize it.
Yeah.
So I think the computer, you're going to give it a span, and then let it just do its thing, and it's going to come up with this organic. And it's going to track the load, and it's going to be all these weird shapes and stuff. And I think you'll just be able to start seeing that. And think, let's say 500 years from now, right? Like really thinking down the road, you say I want a bridge there, right? Or a robot just starts thinking like a bridge should be there, and like
just a drone, a 3D printing drone
comes in and will just print. I mean, really, why is that unreasonable?
I don't think it is.
I think that is. I mean, it's all good. It's gonna be that way. Star Wars will be true one day.
That was in the past.
Yeah, whatever.
He'll come back.
He's coming back, but having flying vehicle, all that kind of stuff.
Yeah.
We won't need bridges.
Bridges.
But a skyscraper, right?
Yeah.
One day, why wouldn't it be to that point? We'll continue to innovate until we get to.
No doubt.
There's no end to it.
Until we don't need offices. We just sit
AI
in chairs and
we're good.
Live in space.
Yeah. So, I think the technologies are just innovating so quickly. It's pretty cool.
Yeah.
I'm interested to see how the construction industry takes on 3D printing.
Yeah, maybe we pose that as our closing question is, what do you guys think? Will there be any pushback from the construction industry? This is taking away jobs potentially of construction workers.
Yeah.
Not always a favorable thing.
Yeah. I think another question too, I would really like to know is like what do you guys think for like earthquakes?
Yeah.
There's just one yesterday up in Alaska, 7.0. Do you think a concrete house would survive that? I bet it'd be okay.
I don't know. I don't think in the current detailing. I think a post-tension concrete house would be cool.
Yeah. Hey, you guys let us know what you think. Yeah, I think that wraps up our concrete houses. So thanks for joining us this week. We'd love to hear from you guys and get your input on both how we're doing and on this topic of 3D printing buildings. All of our information is down in the
show notes somewhere.
Description.
Scroll down wherever you are.
Scroll where you are. Reach out to us. We'd love to interact with you. So hope you guys have a great day, evening, commute, wherever you're listening to us. And I'm Zach.
I'm Max.
And we'll catch you later. Sweet. That was perfect length.